Well, good morning, everybody. Today I want to start off by answering a couple of questions I've received over the last few weeks about the very mild winter. And the questions actually went back to an event that happened in January of 2022, so I thought we'd just take a moment this morning and discuss it. So the first map we're going to look at here is winter. This is our winter temperature ranks. And if I think about this and just try to assess why winter was so warm, most of it had, for me, to do with the lack of major blocking episodes in the North Atlantic, and then at times a very invigorated and extended Pacific jet flooding much of North America with mild air, preventing big blocking patterns, preventing cold air from coming through the United States, except for about January 9th to the 21st. But the questions that I got, many of them in the comments of these YouTube videos, but a lot of emails about this, referred to or asked me if there was any attribution to the very mild winter that not only we saw here in North America, but a lot of the planet, if it had anything to do with the Tonga eruption in 2022. So I'm going to just quickly review this. Here you are. This is east of Australia, and you're getting a time sequence from satellite on the eruption of the volcano. Now, the volcano was 450 meters or so below the ocean's surface, so it's a bit of a unique explosion here in that when it erupted, it vaporized 450 meters of water, of ocean. And had this volcano erupted sideways like St. Helens did, we would have put all of that water vapor into the troposphere, and it would have rained out inside of probably 5 days, given how quick the hydrologic cycle happens in the troposphere. But instead, it ejected this water vapor clear into the stratosphere, where we measured a 10% increase in stratospheric water vapor load. Now, why do we care about this? Well, most volcanoes, when they erupt, they end up putting sulfur dioxide into the stratosphere, which has a global cooling effect for several years. In this particular case, putting a lot of water vapor there gave us a different signal, because water vapor is it's an abundant and relatively powerful greenhouse gas. It's very important to the whole climate system of our planet. All right, so the water vapor's there. What has been studied and what's been known? Well, there's been a few papers that have come out that have looked at this increase in stratospheric water vapor load. What this graph shows is the top of the troposphere into the stratosphere and a little bit above that, looking at, so this is where the pressures are, looking at water vapor. And there's a nice little cadence to the water vapor load in the stratosphere that happens seasonally. You can see data going back to 2004. And in all the records we have, we've never seen, this much. It's a lot that went up there. So the original thinking was that you could get a global warming signal out of this that could fall outside of the natural variability. But we didn't know. And when it's unprecedented, literally that means you don't know. You have to study and try to figure this out. So I know it's been more than, 2 years since this has happened. And we just continue to see very high water vapor load in the stratosphere. So a couple of research papers have come out about this, and I'm going to take you one in a great journal called Geophysical Research Letters that just kind of summarizes the event here and talks about that increase in water vapor load up to 10% and the potential impact that this could have on temperatures. But if we could summarize what most of the research suggests, I'm going to take you to this article here, which looks at this statement. And some forecasts have been done on this, but generally, while we do expect a global increase in temperature over the next 5 to probably 8 years, the amounts don't fall outside of natural variability or noise in the climate system. So you can see here that this was one of the modeled amounts. So we just need to be careful not to attribute one specific event, even though it does have a lasting effect on everything. I've heard a lot of people, just people have shown me and asked me, is this caused because of that? And I don't think we can even relate the warm temperatures that we've had here in the last 3.5 months to this as well. So I just wanted to present that to you and make sure you knew what my thoughts were on it based upon some of the folks that have written peer-reviewed research papers on it. So that's what I know, okay? Why don't we take that from here and go into some satellite data? The sun is trying to rise here along the East Coast this morning. This, of course, being the first full day of astronomical spring. We had the equinox last night, so you can see that our day-night line runs straight north-south. Really like to see that again. But I want to take you back to yesterday and just kind of give you a good view here of North America. We had things kind of clear out, except for the snow that was coming into parts of New England, off the Great Lakes in Ontario, and then our upper level low still sitting and spinning here over Arizona and New Mexico. I'll take a closer look at that. But unfortunately, my flight down to Dallas, I did not get a window seat, so I didn't get to look out here and see any of the smoke from the prescribed burns that are happening in this area. But I did want to take a look at them on satellite. So we kind of just go back and forth here. It is amazing just to see how much smoke got into the atmosphere. And some of the smoke from these fires is pretty extensive as you look across parts of the southeast here, back into the mid-south, and even parts of the southern plains. But I was quite intrigued by this upper level low and its ability to continue to produce some pretty deep convection in parts of the southwest. And I was even looking over here into parts of Arizona and California, and just thought it was kind of fun to watch convection building on the east-facing slopes of the Sierra Nevada mountains. Just kind of a neat feature. So they kind of pop off there and blow off over to California's Central Valley. And of course, since we're thinking a lot about the snow that's coming in this near-term forecast, it was a good day just to see the west. And I wanted to show you the latest snow water equivalent maps for the western United States. So as of March, we can see that so much of parts of the Great Basin, the Colorado Basin, getting here into the Sierra Nevada. I mean, the Colorado River sitting at about 100% of normal, so it's right on average for snowpack, but even more as you get toward the, this section of the Colorado River. Just a great snow, except for when you get a little bit farther north. We needed more in the Cascades, we needed more in the Northern Rockies. But you know that the system that's coming through is going to go a long way to start to work against this. So let's get into that system. The WPC for the preceding event leading up to the big event this weekend and then the one next week, all right, still has decent snows coming in ahead of all of this. So this is the probability through Saturday morning of getting at least 2 inches of snow. And if we step this up to 4 inches of snow, there you go. You're already seeing a decent stripe of snow coming right in through here and more into parts of New England. And there's been some folks in New England that have seen just persistent snow. They're very deep in the interior of these states, of course, but persistent snow for a while now, and it keeps kind of adding up there. But let's kind of step this up one more time. This is, again, is probability. Let's go up to the probability of 8 inches. And we see the heaviest coming out of Alberta into parts of Montana, here possibly in lower Michigan, this part of Ontario, and then deep into the interior of these New England states. All right, that's just system number 1 coming through. I want to go right in and show you what some of the models are up to. We're going to do a multi-model approach to this, and I'm going to start with the ensembles. Now, a disclaimer, I will show you snow amounts, and I'm going to show you 10-day ensemble amounts. I want to make it very clear that predicting snow in March is one of the most challenging things to do because of snow ratios, and the ability for the atmosphere to load with moisture. Sometimes it can just outdo what I expect. There is one problem with the moisture in the system. I'll address it in a few moments, but this is the 10-to-1 ratio number. And you can see the color bar down here. These colors are getting between 10 and 20 inches of snow from the next few events. There's a few coming through this area. We'll look at their timing. I love it for the Northern Rockies, this part of Montana, the Cascades, and the Sierra Nevada. I mean, the whole of the Rockies adding up here. But this is a pretty massive amount of snow. So let's jump into that area, because this is an area that's in major snow deficit. And we'll just go ahead and look at the numbers, understanding that you cannot take these verbatim, right? We've talked about that for years. But we need to have a look at it. We're trying to figure out the placement of the heaviest snow. So this is where the European ensemble is putting it down. Let's go look at the GFS ensemble to see how similar things are. And that's where it has the heaviest snows. Now remember, don't say I'm in Minneapolis, I'm getting 16.6 inches. It's just there is a stripe in through here where the probability of getting at least 8 is very high. Probably some places here easily picking up well over a foot. I want to add to this the national blend of models. This is another forecasting system we have here. And you probably wonder why I don't show you the artificial intelligence. It's because we don't have a precipitation type flag given to us yet in that model. So there is the potential for a lot. I mean, it's really showing up here for the risk of some very, very heavy snow. And just to kind of get away from that map, because I think it's on the more extreme side of things, I'm going to take you back to the European model and just show you. This is through Friday. This is the push coming in Sunday, Monday. And here we go all the way out to Tuesday and Wednesday of next week. And this is what the snowfall totals are looking like. So this is a huge event, and it's going to have major implications on several things. The first of which being to undo what this past winter has done in terms of major snowfall deficits in this region. So I mean, we're going to be hitting these states which have been almost completely devoid of snow throughout this winter. Some of the snowfall differences from normal here are up to 3 feet. So we're not going to make up all of that, but we're going to make a big contribution to it. I've made a case that because of this, flooding along the Mississippi would be minimized. Well, with the snow that's expected to come in, we should be watching the Mississippi now for flooding risk later. Because today it's about 15 feet above low stage, which is good. I like the river being about that level. We're certainly expecting this to get higher as time goes on, especially as this event comes through, plus the rain that's coming through with it. And what I like so much about snow is that snow takes a while to melt. So it may take 3, 4, 5 days once the temperatures warm up to get rid of all of it, which means a really good slow soaking in of that into the ground here. Now, how much cold air we have ahead of it will tell me how much of this is frozen. So we're going to take a close look at the temperatures leading up to this to know if the soil will be frozen over, which means we don't get as much of the water as we want. But as it stands, I'm only going to go down 16 inches because I want to show you that top layer. This area is really just desperate for the moisture, as you can see here. In fact, the whole of this section of the Mississippi and Ohio Basin, the Great Lakes Basin, part of the Missouri Basin need it. You can also see parts of the interior of New England and North Carolina still showing up with drier conditions, as are the southern and central plains, which we've talked a lot about lately. One neat thing to do here is just to show you where we currently stand in terms of snow water equivalent. So this is what we have now. If you took a quick look at the west earlier, you can see what's already here in parts of New England through midnight last night. But this is where we were a year ago. So in other words, we're going to put a lot of this back in place. And now this was not from March last year. This was from January and February. It was still lingering here, still quite cold. So we're going to go back to this area in terms of getting snow water equivalent numbers back high in this region. So this is an absolutely critical event that's going to be taking place, and we just need to talk about the timing and take a look at what the models are suggesting for it. So where it is right now, it's this broader trough that's underneath this split flow in the jet. It's looking like this, I think, largely because of the upstream high over low setup we've been talking about for more than a week now, that omega blocking pattern that's evolved into this that is kind of bunching up the flow. But it's giving more time for these troughs to kind of work together. There's 1, 2, 3 of them, and there's still a good push behind this from the Pacific jet, which means this is going to come across the country, and it is going to be an impactful event. But because of how subtle these features are, I want you to know that the exact position and timing of these systems is not well known yet. They're not over North America for us to really dig into. But it's this mess right here. So there's the ridge that moved into Alaska. That had to happen to let the cold air get in here. And before this system gets here, don't forget, we need to watch the combination of this trough here and the broader trough that's sneaking through the eastern United States. And I'll show you why in a second. But as we play this forward through Thursday into Friday, that trough sneaks across the southern tier of the U.S., a place that's had excessive amounts of rain so far this winter and early spring. And these two troughs interact and work together to produce a system that goes up the East Coast. Now, I'll be honest with you. I mentioned a moment ago there might be an issue with this next system not having access to a deep, unstable, loaded with moisture amount of air. And the reason for that, I was talking with my good friends and colleagues Matt Reardon and Andrew Pritchard about it, is that this low sitting in this area on Saturday ahead of when this deeper trough comes, sweeping in like this is kind of ruining the environment. You say, what do you mean? Well, I'd rather have, if we're going to get a big resurgence of moisture, you want a high pressure cell here to open this up and just send moisture all the way back through the plains deep into the northern reaches of the United States. So this guy kind of gets in the way, but it will produce a system that kind of lingers here along the East Coast. So we don't have the great setup ahead of this system, but it doesn't matter. I think it's going to be powerful enough that it will be able to make a good pull on the moisture and produce that snow we talked about. It's slower. So you see here from Sunday into Monday and Tuesday, it just goes from Arizona up to Minnesota. So it takes a good 3-day trek across the United States. And then as it leaves east, we don't finish. We still have another low that comes in on Saturday the 30th, getting into Easter Sunday here, dipping right into the same area. So even though I only showed you out 10 days, I want you to understand that there's another low following with similar characteristics out there around Easter weekend. Okay, so what do we have ahead of all of this? As of 5:50 this morning, we still had red flag warnings out here for stronger winds and the fire risk. We still have the frost advisories to the south, but the rest of the country, it's along the northern tier of the U.S. where we have the kind of indications of this next couple of systems coming through. So let's pick this up at 7 a.m. Wednesday morning and just kind of play through the day. There's Wednesday afternoon and evening. We do have the chance for some stronger storms in here, like we talked about yesterday, coming out of the front edge of the upper level trough that's spinning over to Arizona and Mexico. So again, more lake effect snow and convective snow bursts here in New England to deal with. But you see the first stripe of snow coming down on the edge of high pressure right in through here. So this is kind of, it's upslope here, but this is air that's being lifted, partially aided by change in elevation as well, but there's some good dynamical lifting there too. That's tonight, getting into early Thursday morning. Now, as we play through Thursday, we have two things to keep an eye on. Snow is going to spread from Alberta through South Dakota toward Minnesota by Thursday night, and you're going to see some storms ripping off in parts of Texas and Louisiana and spreading into the south. These are the two lows, okay, so the one that swept in like this, the one that came out of Arizona, that are going to be coming together east. This is the one that's going to kind of ruin the moisture return and unstable air return in the midsection of the country. But this is early Friday morning through midday Friday, and we could get some very, very heavy rain out of this as the snow which started here pushes into the Great Lakes states. Now here's the main event. It's just now coming into the coastal parts of Washington, Oregon, and California. So that's the big system that's going to follow this. But what we need to do is we need to kind of assess what we may be able to get in terms of total moisture just in our next 7 days. So I'm going to give you a 4-model approach to this. Our first map is from the WPC. And again, I still think we're struggling to draw a lot of moisture back past west of the, the 100th meridian. Secondly, the Canadian Prairie is where the coldest and driest air is kind of anchored in through here, so I don't expect a lot there. And finally, the upper level low leaves the Four Corners states, and so we're going to back off a bit. But there is, according to the WPC, as much as 1.5 inches to possibly 2 inches of liquid in all of this, centered right on top of one of the driest spots in the Corn Belt, Iowa into southern Minnesota and this part of Wisconsin. Where we don't need this moisture is down here. This is an extremely wet area, but it's good to see it coming back into the Carolinas and going up the East Coast. This is the artificial intelligence forecast, and similar. You can see the moisture amounts coming in from the AIFS system. Heavy, heavy rains down here again, where we've experienced already a tremendous amount of moisture this year. And here's the European operational run. So we're getting a very consistent picture, and finally, this is the GFS operational run. So you see multiple models giving us very similar outlook for the pattern as it evolves. Now, I kept mentioning a place that doesn't need the moisture. And just to show you, since this year began, we have some places down here that are more than 10 inches ahead of normal. And so to see more rain coming through, we're going to see the flood threat continue in this area. And it's just amazing to think about this because the state of Louisiana, almost the entirety of it was in D4 drought last fall. So major, major recovery and drop, but now we've gone almost over to the other extreme. So this is a departure from normal maps since the start of this new year. All right. Okay, so finally into the models. I do need to apologize. Again, I'm on travel for work, which means I couldn't fix this when from home. But the European model had a couple of frames with some glitches in it. You'll see them in a moment. But we've already played through this in the high-res 0. So there comes the two systems that lead. One to the south, one to the north. This one spreads snow through parts of the plains, upper Midwest, and Great Lakes. So as we get these systems together up the East Coast, very heavy rains coming out of the south, moving right here into the mid-Atlantic after going through the Carolinas. That's in both models. Snow coming out of this part of Ontario into New England and right there, okay? That's through Saturday morning. This is the next big system here. Now you'll see, there's my bad frame. I apologize for that. This would be crazy, but that's not what's happening. Let's get on to the next one here. There we go. Into Sunday morning, playing out into Sunday midday, Sunday evening. This is when the next large system ejects and moves forward. We got here Monday morning, Monday afternoon, and evening. I will mention that the European models seem to have slowed down, matching more of the GFS solution in this case. And we can see where that heavy snow is expected to be through Tuesday into Wednesday, with the southern part of this possibly having severe storms that start maybe in the Red River of the south and moving over toward the Mississippi basin as we get our way in from Monday night into Tuesday night. As we then play forward into Wednesday and Thursday, that system's out. And then, as I mentioned, another one is already kind of loading up here as we approach, Easter weekend. So we'll keep an eye on that. Now, do note one thing. As we go out here longer range, now this is way out in an operational run, the GFS is tossing another system through here before this next big one. So it's got an extra little shortwave that sneaks through that's not really well resolved in the European. But this is out here next Friday. So we'll keep an eye on that. But right now, we're not going to put a lot of trust in these operational runs. What I do want to do is put it all together for you in terms of total amounts of precip. We're going to start on the drier side. Spent a lot of time yesterday talking about this risk here of the chance of staying under 1/10 of an inch and the dryness in the Canadian prairie. But on the wetter side of this, let's go get that old model run here. We'll go out 10 days. There we go. These are the probability maps of getting 1 inch of liquid out of this. So this, again, is an area that desperately needs this, does not need it down here. Here's the probability of 2 inches. So there is quite a bit of moisture in this, despite the fact that the leading system robs the moisture in the unstable air from the next system that rolls through this weekend. Okay, from here, let's just go have a quick look at week 2. As I mentioned, going through Easter weekend, we don't slow the pattern down. There's another trough that comes in, and it sweeps across the country. It is important to note that right now the models have trended a bit drier in this area. That's been a major concern of mine for a while, as you know. So from here, why don't we take it to a temperature discussion, and we'll add in any new long-range information and wrap this up. Here's our frost risk today. Again, this morning we were talking about this area early this morning. But as we look at the temperatures, I'm questioning what the temperatures look like ahead of the system coming through. So here's Thursday into Friday. What I want to see is these temperatures above freezing right in through here. All right, so above freezing. That's Friday getting into Saturday. Now this is when we're starting to get the system to come through. Without, with getting high temperatures back up above freezing, this means we won't put a hard crust on the ground so that the snow can't melt into it when it's done. So that's important. Look at the front range though, the flow coming off of it, downslope, very, very mild. That's Saturday, getting into Sunday and Monday and Tuesday as that system evolves. So you can see we're flirting here with near freezing temperatures during the daytime highs. And that's what's going to be critical for allowing this snow to fall on, ground that's not frozen down to 16 inches, which it can be during this time of year. Looking beyond that, this is the day 5 through 10. And so the models continue just to put down, over the top of that snow, the coolest air, and day 10 through 15 reflects it as well. There's some snow feedback in this, but that's what we see. It's also in the European model. That's day 5 through 10, and then this is day 10 through 15. So that now gets you out there into the first full week of April, and we've been discussing about the chances of a bit more of a moderating pattern at that time. So I've been showing you the European model, which has shown cooler end of March, cooler start to April, more mild mid-April. So that's been a theme in the European model. I'm going to show you the GFS extended now. So this is the kind of starting point. Let's get you out there. This is the last week, there it is, of March, which we've seen. And as we play forward into the first week of April, the GFS is cooler as well, except for the parts of the Canadian prairie. But then as we talked about, getting into the second week of April, could we expect to get some moderation in the midsection of the country? Possibly. Could we hang on to cooler air here longest? Yes, but remember, cooler here in mid-April isn't cold. And the west is a bit of a tricky forecast overall. I think there's some interesting feedbacks with the snow in the mountains that are kind of biasing this, but we'll keep an eye on this to see if more troughs of low pressure exist in the west going into April. But that's what kind of the forecast looks like. So I'm going to stick with it until I have evidence to overturn that. In terms of the long range, for a discussion about El Nino or the MJO, I don't have anything new. So if you've been following along, I don't have any new really long range stuff to talk about. I'm waiting on one piece, which would be the CPC's new updated 3-month outlooks. They should be doing this very soon. And we'll be able to then compare all of the modeling systems we have. We'll do the analogs again and make sure that you have the full picture of what I think the rest of spring and summer is going to look like, plus a bit of a taste for the hurricane season. This is all old data from from February. So we'll get a close look at that soon. So that just brings me to one other topic, and we'll wrap this up. No change in my forecast for South America. All right. We continue to see good lift here. MJO favoring, phase 6, 7, 8 type dynamics, lifting the lid off of the convection. There's going to be a nice convergent boundary in through here and heavy rain. And this is hitting a dry spot for this safrinha crop. I think this lasts till the end of the month and possibly into the early parts of April. But I still can't rule out that this goes back over dry once we get toward the critical time periods in April and May for the safrinha crop to go through pollination and grain fill. So until I see evidence to overturn that, we'll keep that as our main narrative going forward. No worry about the dryness in Argentina after how wet things have been. And to be honest, southern Brazil needs a break. So I'm going to stop there and tell you all to have a great day, and we'll pick this up again tomorrow morning. Thanks.